In this video, we're looking at making meaning from your clarified spreadsheet. So if you need help getting your spreadsheet to this point, check our previous video about using Google Sheets to simplify your data. So I'm going to start out showing you a pivot table, which is a tool that could be very useful for making meaning from a spreadsheet. So you're going to highlight your data of interest. Normally I would just click and highlight everything, but unfortunately all the blank cells at the bottom are going to come up as kind of gibberish in the pivot table. We don't want those like open spaces. Then we're going to go to Insert, Pivot Table, choose to put it in a new sheet, just because I like having that space. And now you can say, you can define your rows, your columns. I'm going to use rows and define that as urbanization. So it's going to pull up all our urbanization levels. And then for columns, I don't want that. I want values and I want richness values. And I can keep adding more richness values. So I can get averages, basically all those formulas I used in the previous video. Standard deviation. I can use richness again and get a count of how many values there were. So I have my sample size. All right, so now my pivot table shows me my average, my standard deviation, and my count. So it's doing the same thing that I was doing before, but instead of having to enter those formulas and format everything, it's pulling exactly what I want it to pull. Just the urbanization and those levels of richness. And I could add, like, say I wanted to look at kind of the relationship between temperature and richness. I could add a value for temperature and look at the averages there. And I think I can move it. Nope. But I can see that like there does appear to be a little bit of a like high to low relationship that matches the average of the species richness. I'm not sure if that's a significant relationship between the two things, but this is the kind of thing a pivot table can do and so much more, but I am not an expert. So there's some interesting stories here, maybe a potential confounding variable, but I'm going to point you in the direction of other videos for pivot tables like this one. I don't use pivot tables very often, so I'm not an expert, but it's very popular and it's well explained by others. So I'm going to focus the majority of my time teaching you how to use StatsCloud, which is a tool I love and I use all the time. So I'm going to go back to my clarified and simplified data, and this time I'm going to File, and I'm going to download this. I just want the information in this tab. So if I do a comma-separated value file, it's only going to save this tab's worth of data, and then I'm going to statscloud.app, and I'm opening the app. And I'm going to create a new temporary project and import that data that I just downloaded. So when I open that up, you can see it grabs my headers and now they're organized as variables, and then you have all these tools along the side here. So first, this tool, it's showing you all of your variables, so you can click on them. It's telling you, oh, like this is a nominal category, meaning it's names. If you wanted it to be ranked, you could actually rank them and have it ranked 1, 2, and 3. That gives you some other analysis tools, and there is a ranking to this, but I'm going to take it back to categories just because a lot of your categories will probably be categories in name only rather than ordered categories, but you have those two options. You can look at your, richness is categorized as a number. You can even see here, it has the little icons to let you know what it's categorizing as category or number. So qualitative and quantitative, very helpful that it kind of pre-assigns that and then you have some edits. So if I went into these categories, Since it does show me my categories, this would be another place where hopefully you could catch misspellings or extra spaces. In sun, I should only have sunny, partly cloudy, and cloudy, and I do. In other weather, I have windy and rainy, so that's excellent. Everything's looking good. I'm ready to move ahead. This filter here gives you a way to remove or isolate pieces of data for analysis. Most likely, you're not going to want to do that, but I have used that with some of my upperclassmen. See a teacher or try it out if that's something you think you're going to use. If I wanted to just isolate out maybe just rural and urban and leave my suburban data out, I could add a filter. Charts are wonderful for visualizing data. So charts are going to summarize rather than showing individual data points. Of course, scatter plots will show individual data points. So we've got our scatter plot here, but we're going to look at a bar chart first. So I can compare my urbanization levels, and right now they're all selected, and that's what I want. And I want to look at my richness. So what does my species richness look like when grouped by urbanization level? I click Create Chart, and it pops a lovely chart out for me, organized by richness. The levels of the IV are in the order that I set over here. And I can see along here as I scroll, I can change the color of my bars. Ooh, it helps if I click and not right click. I can even change my error bars to be standard error of the mean or a confidence interval. Error bars are the main reason I started using StatsCloud because I was just having so much trouble getting that level of control over my error bars in other tools for making charts. So I have a chart in a few quick clicks. If I want to see the relationship, I can create a new chart, get a scatter plot, and I can look at the relationship between, oh, why isn't it letting me? I would have thought a scatter plot would let me do some of my, let's see. Ooh, will it color code? Maybe so. I just want to look at richness and temperature, create my chart. Oh, look at that. So not only am I seeing my whole scatter, I'm seeing my scatter chunked out by groups. Hopefully I could take away those lines if I wanted to. I am not seeing a great relationship between temperature and species richness right now. The story this is telling is a lack of relationship to my mind, but it was very easy to obtain that, and hopefully I could take those lines away if I wanted to just, oh yes, look at that. I can unclick Show Trend Line and have just my scatter. So lots of options in these charts, lots to play around with. I'm still learning because, I haven't had need to do every possible option this offers. So I can make some statements, general statements about trends. I can definitely show kind of how things are looking, but I don't have information about statistical significance until I go to the analysis button. So this is what this tool is for, is determining statistical significance. I run new analysis and I want to look at differences between my three urbanization groups. So the menu is pretty user-friendly. I had those three groups, so I need a 3+ group comparison. I know I want the one-way ANOVA because it lets me compare the means of 3 different groups within one variable. So I click that, and now I can click urbanization and richness, just like I did before with the chart. And I love the consistency that it's very similar. If you import your data clean, it pops out. And the first thing it starts with is a lovely chart. And you can come over here. It'll add the chart to the charts tab. How nice. Pop back over. I think it gives me some options. I can change the kind of plot, the intervals. Fantastic. But that's not why I'm here. I already made a chart, but my test results. Um, this is all useful information in this chart here. We're going to teach you to include a subset of this in your data tables in APA format. But what you're really concerned with, a couple things to note. First of all, look, you have your average, your standard deviation, and your sample size, just like we had in the pivot table and just like we had in our earlier video here. So same information, only this was obtained with the analysis, and I'll have statistical significance to go along with it. Fantastic. So just as a quick reminder, we set our alpha value to 0.05. That's a standard convention in statistics. There are times and reasons to change it. You're not likely going to have any of those reasons. But what that means is that if we get a p-value right here that is below that alpha value, and we did, we have a statistically significant difference between our groups. But that's a holistic p-value. It doesn't tell us which groups are statistically significant. We've got 3 groups here. They could all be different. Only 2 of them could be different. And so they do follow-up tests. And this is where we can look and see that only one of these p-values, this one right here, is statistically significant. So there is a significant difference between the species richness of rural and urban groups in this fake data. Remember, the data is fake. So that's fantastic. We have our information we need. So I got all of that just from the analysis tab. Why even bother to use the chart tab? Well, the chart tab gives you, you can pop it into the chart, and it gives you just a lot of control. For example, my x-axis only says rural, suburban, and urban. I like to have levels of urbanization. I like to have a little label, an overall label on that. It just looks clean. And when I click off of that, it's going to add it in. I also like to have species richness rather than just richness. I think it's just going to make a little more sense to an audience. Richness was, a short, clean header that I could have in my data table, but on my graph, I'm going to make it a little more specific. And so, you can change the color as I showed you before. If you have a theme going on your poster, a color theme, you can have it match. You can even get down to those like codes like in computer science for the color. So you can be very, very specific here. And I love that. I love that control. You've got control over the font, your border area, and things like that. So it goes on and on. This tool is like, I'm still learning things about it. I'm still learning all the things it can do, but it's a great place to start. As a side note, if any of you love computer science and biology or computer science and statistics, we have a bioinformatics class at TJ, and it uses a coding language called R. And so I just recently realized that when you do analyses in StatsCloud, every click you make, it goes ahead and writes the code for that. And so you can learn a little bit more about how R works. If you're taking bioinformatics or you're working in a lab that uses R, this is a great data analysis tool. It's open source. StatsCloud is open source, and so is the R programming language. So it's just another tool. This can give you a step up. I had to learn how to do all this code on my own. And now, it's a great way to know, hey, if I want to make a graph that looks like this is the kind of code you would use to do it. So take your data, try these tools out, try a pivot table, and definitely visualize those summaries and see what you come up with. Can't wait to kind of try it along with you.